everybody, we're going over parabolas today. Do you remember parabolas? Remember that a parabola is something that's usually we see with a quadratic equation. Okay, so normally we'd see something that looks like, I don't know, like this, right? We'd say that's a parabola. Well, there's a bunch of other stuff inside of a parabola that you may not even be aware of. We're used to seeing the word vertex, right? This point right here, we call that the vertex. And that's kind of where the point where all the rest of the parabola comes from. But there's all this really important stuff. And really what a parabola is a set of all points that are equidistant from a focus and a directrix. And you may be thinking, what in the world are you saying, Mrs. Eldreal? Here's what I'm talking about. There is a focus, and it's always inside of the parabola, and it's a point. We'll call this the F for focus. And there's a directrix, which is a line on the outside of the vertex. And the thing that we know about them is they're equidistant from each other. And the value of this distance, we call that P. So the focus that we're looking for right here and the directrix that we're looking for right here is this always a line. And then the last thing we need to remember is that there's something called the axis of symmetry. And the axis of symmetry is right through the vertex right here. So in the purple, we call that the axis of symmetry. Now, there could be two different kinds of parabolas. There could be one running vertically, or there could be one running horizontally like we see here. So here's the deal. The general equation, if we want to look for this in vertex form, the equation for a vertical parabola is x squared equals 4py. Keep in mind that p is that distance between the focus and the vertex. This is p. It's also the distance between the vertex and the directrix. Okay? Whereas the equation for the horizontal is y squared equals 4py, where again, the distance from here to here is p, and it's also here. Okay? The directrix is going to be y equals whatever the negative p is. So in this case, this directrix is y equals negative p. The directrix over here on the horizontal parabola is x equals negative p, and that's because it's a vertical line if it's your directrix. And the axis of symmetry that we see here is a vertical line where x equals 0, and that's because it goes through the vertex. And similarly here, the horizontal line, axis of symmetry, goes through the vertex as well. These are really, really important. So if you don't have this down yet, this box especially with this picture up here, very critically important, okay? So let's graph x equals negative 1/8 y squared. And we're going to identify the focus, directrix, and axis of symmetry. So step one is that we are going to make sure that it's in the standard form of a parabola, or I should say in the vertex form of the parabola that we just talked about in that chart. So the clue here is we're going to look for what is squared. And we know here it's the y squared. So we need it to look like y squared equals 4px. So if I've got x equals negative 1/8 times y squared, we're going to get that y squared by itself. So let's go ahead and multiply both sides by a -8. And what that's going to do is it's going to cancel out the negative, and 8 times 1/8 cancels it out. So we end up with y squared equals -8x. Okay? Or I could write this as y squared equals -8x. Now we're going to find, so remember, when it looks like this, the vertex is always going to be at the 0, 0, okay? This is kind of, that's assumed, but I don't want to assume that our vertex is at 0, 0. And so now that we know that, we're going to find our value of P so that we can find the focus and the directrix, okay? So our vertex is 0, 0. And we know if y squared equals what we know right here, 4px, since this is x right here, the 4p is equal to 8. So we would say 4p equals -8. Let's solve for p, and we get p equals -2. So if p equals -2, then the focus is going to be, that's going to be the distance from the vertex to the focus. So if this is our vertex right here at 0, 0, the distance to our focus, and in this case, remember, it's going to look like this over here. It's going to be a horizontal. The distance to our focus is going to be -1, 2. And then our directrix, remember, our focus is going to be to the left, so it's going to be -2, 0. And our directrix is going to be the other way, so a negative value of P, which in this case is +2. And that is a vertical line at x equals 2. So once I have that, I'm going to graph it out. We know the focus is always inside the parabola, so it looks like this. And we've got our axis of symmetry right here. Okay, is going to be y equals 0. And then we graph it. Okay, write an equation of the parabola shown. So we know a couple things. We know the vertex is at 0, 0. And we also know, we don't have the focus, but we do know the directrix, if we look at the distance between here to the directrix, is 1.5. Or you could say this is 3/2. So knowing this is a vertical parabola, we can see that here, it's a vertical parabola. I'm going to go back and look at my chart. Remember my chart looked like this here? So I know my standard form is going to be x squared plus 4py. So let's plug that in. Oops, too far. So we're looking at x squared equals 4py. So here's what I know. This is my value of p. So I'm going to plug that in. X squared equals 4 times p times y, which that's all part of it. And we're left with 12 over 2y, which is 6y. And that's my answer. Now, what if the vertex is not at the point 0, 0? What if it's translated? So remember, if it's vertical, it's got a vertical axis. If it's a horizontal parabola, it's got a horizontal axis. Then these would be our translated forms of a parabola, where the vertex is h, k. So it looks very, very similar to what it did before. The only difference is we're subtracting an h inside the x quantity, and we're subtracting a k inside the y quantity. Remember, k always goes with the y, always goes with the x. Okay, write that down. Write an equation of the parabola whose vertex is -2, 3. Remember, the vertex is h, k. And the focus is at -4, 3. So the first thing I would do is I'm going to graph this. Here's my -2, 3. Here's my -4, 3. This is my vertex. Here's my focus. Well, I know the distance between these two is p. And I know the distance is going to be a -2 because I went this direction to the focus. So I know that because the focus is always inside the parabola is going to look something like this. But the crux is I know that the p is -2. So again, I'm going to look up here. And remember, this is the one I'm looking at. So I'm going to want it to look like y minus k equals 4 times p times x minus h. And I'm just going to plug in what I've got. So remember, this h k goes right here. So it's going to go y minus k is 3 times 4p. Remember, p is -2 times x minus h, which is -2. And now we're going to simplify. This becomes add the opposite. And that is a perfectly beautiful equation for that parabola. Lastly, what if I said graph the parabola given? So we're going to break this down into pieces. Remember, this is going to look like x minus h squared equals 4p times y minus k. So here's our h. Here is our 4p. And our k is going to be broken up after we go minus the -1. So we go h comma k is 1 comma -1. And 12 equals 4p. Divide both sides by 4, and I get p equals 3. So our vertex is at 1 comma -1 here. That's our vertex. And to get to the focus, we go a distance of +3. So we're going to go up 1, 2, 3. That's going to be the focus. It also tells me the directrix is 3 below it. 1, 2, 3. So here's my directrix line. Remember, that's always a line perpendicular to the axis of symmetry. Here's my parabola. There's my focus. And here's my axis of symmetry. Done. All right, I'll see you back in class. See you later.